Hello everyone, welcome to Statistics for Machine Learning. In this series, we'll uncover the statistical heart of every machine learning model. As you know, machine learning is a way of teaching computers to learn from data and make predictions or decisions without being explicitly programmed. But before we dive into algorithms or fancy models, let's take a step back. Have you ever wondered, why do we even need statistics in machine learning? The truth is, every machine learning model, whether it's predicting house prices, exam scores, or diagnosing diseases, is really just trying to understand data. And how about statistics? Statistics is the language that data speaks. Without statistics, we might still get the results, but we'd have no idea what they actually mean. So let's explore why statistics is the foundation that everything else is built on. Let's start from the big picture. When people talk about machine learning, it can sound mysterious, but in reality, it's built from two pillars: statistics and computation. Statistics helps us understand patterns and uncertainty in data, and computation helps us automate that process on a scale. I always say think of machine learning as a car. If machine learning were a car, statistics would be the engine. It gives the power and logic, and computation would be the driver's system. It controls, optimizes, and steers. Once you see ML this way, it suddenly feels a lot less magical and a lot more logical. Now that we understand the big picture, let's zoom in on where it all begins, the data itself. In statistics, everything starts with variables, things that we can measure. Maybe it's study hours, sleep hours, and exam scores, but each variable tells a story about part of your data. Some of these variables are numbers, some are categories, and understanding these types helps us decide what models or visualizations to use. Here is a summary about variables types and their features that you can see in this table. So if you want to take a screenshot, go ahead and pause the video. Machine learning doesn't change this. If you don't understand your variables, even the most advanced models will give you nonsense. So once we have our data, what's the first thing that we do? Correct, we describe it. Descriptive statistics is the things like mean, median, and standard deviation that help us get a feel for what's normal, what's unusual, and how spread out our data is. So imagine you're grading a class. If the average score is 70 and one student, for example, gets 20, that instantly tells us something is off. That's exactly what descriptive statistics do. They let you listen to your data before even you start modeling it. In ML, this step helps you detect outliers, bias, and bad data, which are the silent killers of good models. All right, we have described our data. Now let's talk about the part that makes statistics truly powerful: probability. Probability is how we handle uncertainty. Every prediction a model makes, whether it's spam detection or disease risk, comes with some uncertainty. So if your model says there is an 80% chance of rain, it's not claiming to know the future. It's expressing how confident it is. That's why many ML algorithms like naive Bayes, logistic regression, and Bayesian models rely heavily on probability. They don't just say yes or no, they say how sure I am. But even the smartest models can fail if the data feeding it isn't right. There is where sampling comes in. Sampling is a core idea from statistics. Your model can only learn from the data you give it to. If you only train it on top students, it'll struggle to predict for everyone else. We call that sampling bias. And it's one of the biggest real-world problems in machine learning. So that's why statisticians always ask, is my data representative of the real world? Because if it's not, then no algorithm can save you. So, how do statisticians think differently from data scientists who run codes? Statistical thinking is about questioning your results. You don't just look at accuracy, you ask, is this result significant or just random? Am I mistaking correlation for causation? Or is my model too perfect, maybe overfitting? This mindset turns you from a model user into a data thinker. And that's what separates a good machine learning engineer from a great one. Now let's tie everything together. So here's the takeaways. Statistics gives us the foundation, including understanding data, measuring uncertainty, and building trust in our models. Machine learning, on the other hand, automates the process, but it is still stand on statistical principles. In the next episodes, we'll go step by step, starting from descriptive statistics and moving all the way to probability, inference, and hypothesis testing, but explained simply, visually, and practically. I think this series is very useful for those who starts learning machine learning and even for those that just want to brush up on the statistics part of their journey. Because when you truly get to statistics, everything else in machine learning is just clicks. So, as always, thanks for watching and I'll see you in the next video. Bye.